Hello, you're right. Today's lesson is going to be anaerobic respiration. Here's the work folder. What I've done is I've tidied it up a little bit. I've put the old topic in this folder, so if you need to go back to any of the old lessons, they'll be in here. Now here is today's lesson, anaerobic respiration. We're going to start with the PowerPoint, and then I'm going to tell you which of these that you need to do later. So here it is. Right, anaerobic respiration. These tasks I'll give you, well, you can pause the video to try and do them. We really need to remember the word equation for aerobic respiration. This is really important, okay? If you can remember the equation, you should be able to figure out what the reactants are. And if you can remember what the reactants are, you should be able to figure out how they get into your body. This is all from last lesson if you are a bit stuck, and you can go back and have a little look. Again, I'll let you pause to read these. Okay. In which situations would you need to respire without oxygen? And we discussed this last lesson briefly. If you'd like to pause and have a think, that's fine, and resume when you are ready. Remember, we need to respire without oxygen in extreme exercises or intense exercise. We can only get so much oxygen in our body, and if you have to push your body to the limit, say you are a sprinter and you have to do a 100-meter sprint, or maybe you have to fight off a bear, okay? You'll use up all the oxygen that is inside your body very, very quickly because everything is working to the max. Now, if you were to just fall over and run out of energy, that would not be a very good survival technique, and you would get eaten by a bear or any other predator. So we have evolved to be able to respire without oxygen in short bursts. Now, anaerobic respiration, and if you remember, aerobic respiration means with oxygen, anaerobic means not with oxygen. So glucose actually just breaks straight down into energy and lactic acid. One thing to note is that this is not as efficient as aerobic respiration. That is why it's preferable to respire aerobically. If you respire anaerobically, you will produce a lot less energy, okay? And lactic acid is not good. When you are really working hard, the reason why you feel that burn inside your muscles is because you can feel the lactic acid being produced, because it is an acid. Now, glucose is the reactant in this case, and lactic acid is the product. Energy, you can't quite see energy. When you do this at A level, you will find out that the energy actually has a name. It's called ATP. So that will be your products. Now, how is this different? Well, hopefully we know from the equation before for aerobic respiration, and you know what, let's write it down. Let's write it down so we've got a reference. So let's go over here. Right, so aerobic. We know that is, well, we've got glucose, don't we? Plus oxygen. Remember, aerobic means with oxygen, and that makes energy. So I'll put that at the end. It makes carbon dioxide plus water, and then it also, put this in brackets, makes energy. Makes about 10 times more energy actually. It's very, very much more efficient. Well, let's have a look. This is the same, and this is kind of the same, but this is different. Anaerobic respiration does not use oxygen, it does not make carbon dioxide, and it does not make water. So that is how these are different. As a side note, well, actually we'll get onto it later, I won't confuse you just yet. Now, anaerobic respiration does not use oxygen, transfers energy from glucose when there is not oxygen available. It often happens. Let me edit that. Often happens during strenuous exercise. Now, why don't we use this all the time? Well, aerobic respiration is more efficient. And lactic acid causes cramps in your muscles. Okay, it's painful, your body needs to get rid of it. What actually happens is that lactic acid needs to be broken down. You have an oxygen debt later on, and you use oxygen to break down that lactic acid back into carbon dioxide and water. Now, I'm going to skip this slide because we don't want to do this just yet. If you look here, when you've finished exercising, you keep on breathing heavily. This is called oxygen debt. If you do a very strenuous exercise, while you're running, you're breathing quite a lot, okay, because you need the oxygen in your body. But when you finish, you're still out of breath for like a minute, maybe, or two, depending on how fit you are. That is because your body still needs the oxygen that you couldn't get earlier. So even though you can respire without oxygen, your body still needs that oxygen at some point. So that is why we call it an oxygen debt. Now, the extra oxygen that you breathe in breaks down that lactic acid so you can get rid of it later. Okay? So, let's go back one. We're going to go to this task. Now, this here, it says Group Task Anaerobic Respiration Worksheet. So I'd like you to open that, please. And we're going to go through this together. It's quite a difficult task. Now, but I think it's a really good one. So, hypothetically speaking, let's say we could test the blood of an athlete while they were running. So here's the blood lactic acid concentration. Ignore the unit. It's basically how much lactic acid does this person have in their blood. And here's the time. Now, you can see the graph like this, and you can see some letters. So they've given you a section of a race. So A to B is from here to there. It's asking whether it's aerobic or anaerobic respiration, and why do you think is going on. So we've got to talk about what the runner's doing, provide evidence from the graph, and say what's happening. Well, we should know that anaerobic respiration is this. Now, it is glucose, and it is broken down into lactic acid plus energy. Right? So, the easiest way to spot if something is aerobic or anaerobic is by looking for lactic acid. If there is lactic acid being produced, as in if lactic acid is increasing, you are anaerobic. If it is staying the same or going down, you must be aerobic. So let's have a look. From A to B. So let's do A to B. Okay, and people have decided to email me work, so I'll just close my email so we don't get interrupted too much. Close all windows, there we go. Now, if you look from A to B, you can see that the lactic acid starts here, the lactic acid concentration, I should say, and it ends there. So we have gone up. The concentration has increased. So A to B, this must be anaerobic. Right? From B to C, well, the lactic acid concentration pretty much stays the same. So if it pretty much stays the same, although we are not able to pay back our oxygen debt, we are getting enough oxygen to respire aerobically. There is just none left over. Now that is the ideal condition. It very rarely would happen if you were able to maintain that perfect amount of aerobic respiration where you're exerting your body as much as it possibly could go, but you're not producing more lactic acid, you'd be able to run for a very long time. So this is aerobic. Well, C to D, let's have a look. So C to D again is this section. And notice lactic acid starts there and it ends there. Goes up quite a lot. So again, this must be anaerobic. Oh, I spelled that wrong. A-E-R-O-B-I-C. And the last one, well, you can see that lactic acid is going down. So this person is not exerting themselves very much here, so they are able to pay back their oxygen debt. So this must be... Right, let's have a look. Stage of the race. Well, what do you think's happening here? The lactic acid is increasing pretty massively. Well, at the start of the race, you can kind of see it only increases a little bit, and then it increases a lot. This person was ready to go. They were stood still, they were breathing nicely, they were getting themselves ready to start the race, so their body already had a fair amount of oxygen just waiting in the bloodstream. So at the start of the race, they were able to push really, really hard. A few seconds in, that supply of oxygen kind of runs out that's inside their body, and they have to rely on breathing it in, but that's not enough, so they have to respire anaerobically. So this must be the sprint at the start. Well, after the start of the race, I don't know if you've ever watched any of the Olympics or any races at all. Even with bike races, the same thing kind of happens. At the start, they all have a mad rush to get their placement. Then for the middle, especially for a 400-meter race, the first maybe 50 to 100 meters are a mad rush. Then the next 200 meters, they have to coast, otherwise they will burn themselves out. So actually, they're just keeping a constant speed, okay? They are not quite sprinting, they're doing a jog that is just at their speed. So they're doing maybe like a jog at a constant speed. Have you ever heard the term pace yourself? That's what they're doing here. They're trying to pace themselves so they don't burn out. Well, from C to D, they must be at the last 100 meters here. They must be at that final stretch. So what they're going to do, they're at the final stretch, they need to sprint again. Okay, because they want to win the race, right? And then from D to E, they've got past the finish line. They're probably hunched over on the floor, breathing as deeply as they can, trying to repay that oxygen debt. So they are resting here. Now, hopefully that makes a bit of sense. We just need to understand the idea that if lactic acid is being produced, as in it's increasing, you are respiring anaerobically. If the lactic acid is decreasing, you are aerobic respiration. And if it stays the same, you are still aerobic respiration, but you're not taking in enough oxygen to pay back your oxygen debt just yet. So, now, if you look in here again, this is your worksheet that I'd like you to try and complete. Okay. So I'll move it over. There it is. Got task 1. This was the starter. So if you've already done the starter, you don't need to do it again. And there's task 2. I've put it on a Word document for you, just to make it a bit easier to edit. If you want to, you can download the PowerPoint and just edit directly on the PowerPoint if you're able to do that. If not, use the worksheet. Now, if you get stuck, the answers are here. Now, I do still want... If you have not done the exam question from last lesson, at some point you need to do that for me, please. And after you've done that, could you email it to me? And that is everything. So I will see you later.